Okay, so this video is going to look at example 3 from your parametric equations day 1 notes. And example 3 is asking us to convert the parametric equations into rectangular equations. And again, we saw this kind of direction, or this hinting at this idea above in our notes and our definitions. We'll recall that this is also called eliminating the parameter. So another way to be asked to do this is you might be given your parametric equations, x equals t plus 2 and y equals t squared, and you may be asked to eliminate the parameter t. And sometimes you're not told explicitly what the parameter is, but it will be obvious to you as far as what is the variable that is defining your x and your y. Okay, so what all this means to tell us, what we're supposed to do here, what this translates to, is essentially manipulate, manipulate our equations to get rid of t, essentially, right? We want to get rid of that variable t, we want to eliminate it. So we have a couple things that we need to consider in doing this. Our first step that you will see detailed in the answer key to your guided notes, your step 1, is to pick one of your equations, pick x or y equation, and solve for t. So remember that solving for t means, or solving for something means to get it by itself. And I'm going to follow how it is outlined in your notes, and I'm going to go ahead and take the x of t equation and solve for t there, because it's a little bit less intimidating, right? To solve for t here, to get t by itself, all we have to do is subtract over the 2. So what we've done is we've taken our x of t equation and we've manipulated it to show us that t can be said to be equal to, or the same thing as, x minus 2. So what that allows us to do is go ahead and plug that in. We'll substitute or plug that in to the other equation. Okay, our other equation is right here, this y equals t squared. So instead of y, I'm going to say that it used to be y equals t squared. Well, now I know that t is actually x minus 2. So instead of squaring t, I'm going to have x minus 2 squared. And I'm going to go ahead and choose to leave my equation like that. You could, if you wanted to, actually simplify this a little bit further and do your repeated distribution or your foiling to get that into a quadratic in standard form, but it's sufficient at this point to stop, because what we've accomplished is our goal, right? We went from an equation in terms of t to now an equation in terms of x and y, which is what we know to be a rectangular equation, right? Remember, your rectangular equation is some sort of equation that is represented just using the variables x comma y. So we're nearly done. We do have to consider that the parameters, or the parametric equations, were defined on a very specific interval. This was happening between t values of -3 and +3. So we need to come up with the corresponding interval or restrictions on x. So our final step of this is to calculate restrictions on x given those on t, right? We have restrictions from our prior input value, which was t, and now we have to go ahead and kind of come up with corresponding restrictions for our new input value, which is x. So if you'll notice that when t equals -3, So again, I'm going to look at my bounds on t. So we know that one of our bounds is t equals -3. We needed to decide what is x. So we can do that by utilizing our equation up here, our t equals x minus 2. Okay, so if t, well, and actually, it would maybe be more straightforward to use our x of t equation, what we were given in the first place, right? We are told that values of x can be found by taking values of t, so here that would be -3, and adding it to 2. So when x is equal to -3, when t is equal to -3, we find that x is equal to -1. Then we need to analyze the upper bound of t, that when t is equal to 3, we want to know what is the value of x. And so we can find from our equation of x of t that when t is equal to 3, x equals 5. So this tells us that our rectangular equation, our y equals x minus 2 quantity squared, is happening on the domain -1 less than or equal to x less than or equal to 5. So our final answer is all of that together. So our answer is the rectangular equation y equals x minus 2 quantity squared when x is greater than or equal to -1 and less than or equal to +5. Since we had that restriction on our t, we need to go ahead and convert that restriction to x. If we didn't have a restriction on t, we would not need to worry about a restriction on x. Okay, so let's go ahead and look at example 4. Example 4 is going the opposite direction. It's saying, let's start with a rectangular equation and write it in parametric form, given the fact that our parameter t is defined to be 2 minus x. Okay, so our first step here is we want to go ahead and actually we want to use that that definition of our parameter, right? This guy right here, the fact that t is equal to 2 minus x, and we want to solve for x so that we can use that in a substitution in our next step. So, and our first step is to solve t equals 2 minus x for x. And all that tells us to do is take this equation here and get x by itself. Okay, so given that t is equal to 2 minus x, I have a couple options. I notice that x is negative, so I'm going to actually add that over to the other side and get that t plus x is equal to 2. And then I can subtract over my t, my t, to find that x is equal to 2 minus t. Okay, so this is one of my parametric equations. Remember, we are looking at our parametric equations. Our goal here is we need an x of t equation and a y of t equation. So notice here, kind of highlight it to point it out. Notice here we have x defined in terms of t, which means that this right here is our x of t equation. Our x of t is equal to 2 minus t. So now what we need to do is we need to take our y equation, our y equals 3x minus 8, and we need to express that in terms of t. So instead of writing x, what we can do is we can utilize that the fact that x is the same thing or equal to 2 minus t, and that's coming from this x of t equation over here. So instead of writing y equals 3 times x, we'll write y equals 3 times 2 minus t, and then minus 8. So we could leave it in this form, but there's some easy, straightforward simplifying that can be done that I think is worthwhile just because it makes things look a little bit nicer, right? We can distribute our 3 through and find that y is equal to 6 minus 3t minus 8, which will give us that y of t, right, our function of y in terms of t is equal to negative 3t minus 2, where that's all we've done is combined in that last step the 6 and the negative 8. Okay, so our final answer here, our parametric equations, are x of t is equal to 2 minus t, and y of t is equal to negative 3t minus 2. Okay, so again, we needed to find two equations, right? We needed to define y and x in terms of t. Okay. If you look at the rest of the notes that are posted, you now have a few practice problems that you should go ahead and try on your own. If you're stuck or you want to check your work, go ahead and check out the answer key that is also posted. And if that's not helpful, make sure you're emailing Mrs. Bossy or Mrs. Flom or checking out the videos that go over those practice problems as well.